Okay. Now what we're doing today is we're dividing rational expressions. Yesterday we multiplied, or kind of the last few days, last 3 lessons, we went over multiplying. And I mean, we spent a decent amount of time on it, not so much that y'all needed it, but I wanted to go through more than a few examples. I wanted to hit a few of every type so that we can kind of see the different ones. Now, what we're doing today is dividing rational expressions, or really we can say we're dividing fractions. So 2/7 divided by, let's say, 2/5. So how would we divide these two fractions? Mm-hmm. Now which one do we flip? Mm-hmm. Right, the 2/7 stays the same. We flip the 2/5 to 5/2, and what else? And we multiply.
That was such a sketch. That was such a I haven't used fractions like this.
So we flip the second one and change it from division to multiplication. And then we can just multiply the top. So 2 times 5 is? 7 times 2 is? But this would reduce because really, because we didn't even have to do that, because the 2 and 2 would leave us with 5/7. Yes? Now, we still have restrictions because the denominator cannot be 0. We cannot divide by 0, correct? So I'm going to do some. So we look at this here and what we did the other day. Let's see here if I can get a highlighter. Because we talked about x minus 2 and x minus 4. Both of these cannot be 0 because if either one of them is 0, we plug in a value of x that would make them 0. We're dividing by 0, yes? Is there any other place that we'll need to look at for these here? Because there is going to be one. Yes. We're now having to look at x plus 3. Because if, let's just say I plugged in a value here, well, that would be what? -3, yes? Because -3 plus 3 is what? 0. Okay. So if this becomes 0, well here, -3 minus 4 would be -7, yes? Over here, -3 plus 7 would be 4. -3 minus 2, well, that would be -5, yes? So even if we're not flipping it, we're just leaving it as this here. Well, 0 divided by 7 is 0, yes? Here I have -4/5. Well, wait a minute. What am I doing here? I'm now dividing by 0. So really, we can't have the denominators be 0, but also since this whole thing is being divided by, it's on the bottom of the fraction essentially, it cannot be 0. Does this make sense? So now we're looking in more than one spot. So this here's the first one we're going to look at. Now, on a whole, what we're doing yesterday and what we did Thursday and Friday of last week with multiplication isn't too different than what we're doing here. It's really, I know that we're given polynomials, but are we ever really dividing fractions? Well, no, we're doing what? We take division, we flip the second, and change it from division to multiplication. Because we never use long division on fractions, because we don't do that because we're talking about decimals. We'd have to convert it to decimals. So this here is very similar to our multiplication. So if we wanted to, really, we can go on and say, because we have 7x over 2x minus 10, and we can change it from division to multiplication. And we flip the second one. So we're really changing it from division to multiplication. Now we're doing exactly what we did yesterday. Now that we have it flipped, we can go on and factor and simplify these as far as we can. So how can we factor 7x? We can't, because 7x is the only term there, and it's to the first power. That's as simplified as it gets. So what about 2x minus 10? 2 and 10? No, you're good. Because if we look at the 2 and 10, right, if there was an x between both of them, we could factor that out. But 2 and 10 have a greatest common factor of 2, so we can factor that out. All right, there's not an x in common, but since there is an addition or subtraction, they split the two terms apart, so we can look at them individually. Because that's a little bit different than the 7x on top. And 7 times x, it makes it a term, so we can't really pull something out of it because it's already by itself. So here, the 2x minus 10 is considered separate, but it's still considered together. For greatest common factor's sake, it's considered separate. For simplification on top and bottom, they're stuck together. Does that make sense? Okay. What's going to be easier to factor, x squared minus 11x plus 30 or x squared minus 6x? Okay, why is that? There's 2 of them, and what would we do? Yeah, we'd factor out an x, because it'd just be x factored out. If we factor an x out of x squared, I'm left with minus 6. And we're just pulling one x out of both. It's a little bit easier to work with, yes? Okay, so let's look at x squared minus 11x plus 30. So we'll have our 2 sets of parentheses. Now, what are our signs going to be? Negative and negative, because 30 is positive, so the signs are the same, and they match the sign of the middle term, which is negative. What are the factors of x squared? X and x. Okay, well, factors of 30 are 1 and 30. 10, not 2 and 10. It is, 2 is a factor. 2 and 15, yes. 3 and 10. 4 is not a factor. 5 and 6. Which one of these factors do we want to use? Why do you kind of lean towards 5 and 6? Because I have x minus 5 and x minus 6. If we use those, well, I have an x minus 5 on top and bottom now, don't I? Yeah, I have an x minus 6, because if these work out, I don't have one thing that's simplifying, I have 2. And this here, it's not always going to work out that we get, when we factor it, that we get 2. But this is what we're hoping for, because I'm hoping something will match on top and bottom. And if we check this here, that'd give us negative 6x. Minus 5x gives us negative 11x. So, hey, it works, because that's what we want. We want something in common on top and bottom. So if we get the chance to have something that's in common on top and bottom, I'm going to lean that way, because it's kind of nice, because it starts giving us roadmaps or kind of hints at what the factors might be. Okay. Now we can multiply these together, yes? What's the simplest way to do it? I just extended the line, right? Because, I mean, what we could do is I could rewrite everything back on one fraction, yes? But isn't that the exact same thing as just connecting those 2 lines together? Okay, let's cancel stuff out. What cancels? And Sarah, I think you had, yep. I think you're going to say the x's, yes? So what's left? Okay. I was just making sure. 7/2. That's all that's left. So they set this one interestingly enough that it worked out that all the variables simplified out. And we're just left with 7/2. Now we still need to look at our restrictions because we need to see what can x not be. But we have our x minus 5 because that was in the denominator. We also have x minus 6. So that takes care of this one, and this one, yes? But we also need these two here, right? Because I can't have anything in that second fraction becoming 0. Because I can't have anything in here becoming 0, yes? So what additional things do I need to add to the list? So we need this one here, right? X minus 5? Wait a minute. Do I have it? How about the x minus 6? It's already there, yes? Because anything that's already listed, we don't have to list it more than once. Because it's just going to retell me that same 0, yes? Because x minus 5 here, well, that's going to have the same 0 as this x minus 5, yes? Okay. So if I want to see what value of x is going to make this 0, well, we would set it equal to. So, and 0. Right, whenever we have that variable by itself, there's nothing added or subtracted to it. It's just going to end up being 0, because x equals 0. Questions on this here? Okay. Oh, nope, just went to the top of the page. Let's look at this one here. Now again, we can normally start out by trying to factor it, but why don't we go on and change it? Change it from division to multiplication. Because we got to flip them anyways, why don't we just start out with flipping it? So we went on and flipped it because we don't do divisions with fractions. So we changed it to multiplication. Now, 11x, well, that's the same as 7x. Not the exact same, but we can't do anything with it. Because 11x is going to be as simplified as it gets. There's no common factors between any of the terms because, well, there's only one term. So it's as simplified as it gets. So let's look at 3x minus 9. So we can factor 3 out, yes. Which would leave us with? All right, do we want to simplify x squared minus 8x plus 15 or x squared minus 5x? Okay, let's look at x squared minus 5x. So what would I need to do to simplify this here? All right, we can factor an x out. And if I factor it out of x squared minus 5x, what are we left with? Okay. So now we're left with factoring x squared minus 8x plus 15, yes? It actually works out. Since 15 is positive, the signs are the same, and they match the sign of the middle term, which would be negative and negative. X squared would be x, and hey, 3 and 5 are factors of 15. And if we check this, x times negative 5 would be negative 5x. Negative 3 times x would be negative 3x, and hey, negative 8x. We'll see one here in a minute. I thought about skipping over this one because it works out that almost everything simplifies. Because if we start simplifying, connect those together, yep, and we get rid of the x's, x minus 3, x minus 5, x minus 5, well, that leaves us with, Now, it could also work out that we get 1. Because instead of having 3, if we had 11, well, 11 over 11 is 1. Because it is possible that everything in the numerator and denominator simplifies with each other, that everything matches up. It is possible for that to happen. Now, we still need to find our restrictions. Well, for this here, we have x minus 3, x, and x minus 5. Now, again, that second half of the fraction, we already have everything listed. So we don't need to list anything else on top of this. So what would our restriction for this be? 3, 5, and 0. Because this one here would be 3, 0, and 5. Questions on this here? Yep, awesome. Let's look at the next one. See if I can turn the page. There we go. Nope. I want to do this one. Because that one there is going to do the same thing. Everything's going to simplify out completely, and then we'll be left with a number. That's why I threw a few of these in here that won't do that. Because, I mean, if they all work out to be the same, it doesn't help us too much. Nice to see a little bit of something different. Now, when we look at this here, because again, we have something a little bit stepped up, because this is, especially some of the factoring are a little bit harder than what we did on the previous one. Yes? But before we get into it, we're going to change it to multiplication. Because 4a squared minus 1 and a squared minus 4, well, those don't change. The second one, we are going to flip it. Since 2a minus 1 was on top when we were dividing, it is now going to be on bottom. Since the a minus 2 was on bottom, it is now going to be on top. Okay. Now, for this first one here, we have 4a squared minus 1. That's actually not too bad to factor. Because what kind of special factor is it? Or special factors does it have? It is a difference of perfect squares, because it's 4 a perfect square. Well, a squared is also a perfect square. 4a squared is a perfect square. Is 1 a perfect square? Well, yes, it's a perfect anything. Square, cube, fourth, fifth. So this here would be a difference of perfect squares, yes? So 4a squared would be 2a and 2a. 1 is, well, 1 and 1, and we have opposite signs. Since 4a squared minus 1 is on top, it's going to stay on top. Because we only flip the second one, we don't flip the first one. Which A?
1. Yeah. Because a is always equal to 1 until given a good value of 1 is a.
Well, A is 1, because A is just going to be considered a variable at this point, so we could consider A as 1, but that would be considering it as a specific case. Because A is considered to be any value, positive or negative fraction, rational, complex, irrational, any number. But when we set A equal to 1, we've essentially solidified it that this is its value. So on the most part, this here, A and 1 are going to be two different values. because it could be the case that A is 1,
Right.
but it's also the case that A is not 1 at the same time, because it's not defined until we set it to be a value.
Okay.
All right, let's look at the denominator. A squared minus 4. So A squared and 4, well, those are perfect squares again, yes? So we would have A and 2, and the signs would be, so A plus 2 and A minus 2. So they're almost the exact same, but the signs are different. And it works out A minus 2 and 2A minus 1. That's as simplified as they get, because they don't have a greatest common factor other than 1. Now, these here do technically have parentheses around them. Even though we don't write them in, they are still there. We can connect those two. Now, what simplifies? Yep. And 2A minus 1, yes. A minus 2 and 2A minus 1 will both simplify. So what does that leave us with? Now, we still need to look at our restrictions. What A cannot be. So A plus 2 is one of them. A minus 2 is another. And then over here we have 2A minus 1. And we can check on top, well, it's A minus 2. We already have it, so we're good there. So the numerator of the second rational expression didn't add anything because we already have it. So looking at these here, well, A plus 2, if this equals 0, what's our restriction here? Negative 2. If A minus 2 equals 0, well, this one here gives us, what about the last one? It would not be 0. So this one here, on some of them, if it's harder to see, let's just go on and solve it. So I would add 1 to both sides, yes? Divide it by 2. So 1/2. So the last value that A cannot be is 1/2. Any questions on this here? All right, if we're good with this here, let's look at another one. Look at this one here. We have y squared minus 9 over y squared divided by y to the 5th plus 3y to the 4th over y plus 2. Well, again, we don't care about division. We're going to change it from division to multiplication. So we keep the first fraction the same and we flip the other one. I did not. That's what I get for trying to think and write at the same time. I also have to be careful about thinking and driving at the same time, because if I don't pay attention, I'm going to go to one of two places. I'm either going to go home or I'm going to go to work. If I don't think about it, I'm going to 1 and 2. Yep. I've done that on more than one occasion. Where I get about halfway to where I'm going and realize I passed up where I actually needed to go. All right, let's look at this here. Y squared minus 9. How would that factor? what can we do? Difference of perfect squares. So that would be what? And I have a feeling y'all are starting to like difference of perfect squares and you notice them, yes? Because we pretty much square root them. Well, square root of y squared is y, square root of 9 is 3. Y and 3, opposite signs. Well, y squared, not much we can do with it there. It's as simplified as it gets. Now on top we have what? Can we do anything with that? No. How about the last one? Y to the 5th plus 3, y to the 4th. We can take out y to the 4th. Now what does that leave us with? A lot of y's. Like hanging out with a 5-year-old, right? Okay, so we can multiply these together. So the y plus 3 and the y plus 3. Anything else? So the y4 and y squared are both on bottom, yes? Now, it might be tempting. Let me get a highlighter. Kind of talking about these here, maybe. But that y plus 2, lock those two together. They are considered y and plus 2 and y and 2 up top are considered two separate units. These are two different terms. But because of the addition, it locks them together. They have to stay together. So if there's something in common on top and bottom, I have to have y plus 2 and y plus 2. They both need to be the same. So unfortunately, we can't simplify those there. But on bottom, on top and bottom, yes. Right, because y squared times y to the 4th, y2 times y to the 4th would give me y to the... So we can combine those. We can't simplify them out. They won't eliminate out because they're on the same side. They're both on bottom. They won't cancel out, but they can combine. Right? But we can't just say 2y minus 1. We can't just add or subtract those because they're being what? They're being multiplied together. They're being multiplied together. So we have this left over. Now, we need to figure out what y cannot be. We need to figure out our restrictions. Well, we have y squared and y to the 4th, yes? So is the restriction for y and y to the 6th going to be the same thing? Because we're trying to see what causes these to equal 0, yes? Well, y equals 0. Okay, well, that's done, yes? What times itself 6 times would be 0? But still 0, yes? Because we're just multiplying it more than once. So really, y to the 6th and y, whenever we just have a variable by itself, no matter how many times we have it, 2 and 4, it's still going to be 0. Now we have y plus 3 on bottom also. And let's look what's on top. Well, oh, this is different because now we actually do have something on top of the second fraction. So we'll need to include a y plus 2. So this here was our answer. And we already said y cannot be 0. Yep. And that's it. Yep. Questions on this here? Aha. Well, I'll find this at least interesting. Now again, the first thing we'll do is flip it. So the a cubed plus 4a isn't going to change. The a squared minus 16 isn't going to change. But we flip the second fraction, so the a squared plus a minus 20 goes on bottom. The a squared plus 8a goes from being on top to being on bottom. So they flipped. Just flip them over. So looking at these here, what do we think is going to be easier to factor first? The a squared minus 16 or a squared plus 8e plus 15? Okay. They would both be plus, yes. So we'd have a and a, because that's the only way we can multiply a together and get a squared. And 5 and 3, yes. Because those would be the factors of 15 we want. And if we did check it, we would get 8a as the middle term. So it does work out. I mean, a squared, the other factors would be a squared and 1, but that doesn't help us for this here. What do we want to factor next? A squared minus 16. Well, hey, a squared is a perfect square. Is 16 a perfect square? Okay, so I'd have a minus, what, 4? And a plus 4, yes? Okay. Let's look at the numerators. What would we do to a cubed plus 4a? We could factor out an a, which would leave us with what? Mm-hmm. So what are the, because a squared and 4 are both perfect squares, yes? So we have a difference of perfect squares. Well, is a squared plus 4 a difference of perfect squares? Difference would be what? Subtraction. Difference would be subtraction, so we don't have that, so it doesn't work that way. Did we have a sum of perfect squares? Well, we had a perfect, or sum of perfect square trinomials. Well, tri means what? 3. We don't have 3 terms, do we? So is this factorable? Technically, yes. Technically, yes. But not real factors. They're not real factors. Yeah. So a squared minus, or a squared plus 4 doesn't have real factors, so we're not going to factor it. Because we don't want to bring those imaginary terms into this if we don't have to. Now, the last one we have to look at is a squared plus a minus 20. Well, we know the signs are going to be opposite because of the 20 being negative. Our factors of a squared are, and what would be the factors of 20 we want to use? 1 and 20, 2 and 10, 4 and 5. I'd say 4 and 5, yes? Which one would be positive? Which one would be negative? Because, hey, I have an a plus 5 on bottom, and I do have an a minus 4. And it does work out that these are the correct factors. Now, again, we're going to be a little bit lazy and just draw a line to connect the two because they are being multiplied together. So it simplifies. Yeah, an a plus 5 and a plus 5. Which leaves us with a times a squared plus 4 over and this here would be our answer. Now, when we look at the restrictions, so we do have an a minus 4. we do have an a plus 5. So we have these two here. I want a different color. I'm going to go with purple. Because we also have a plus 4 and a plus 3. And as y'all remember, as I said the other day, I disagree with the book on this, and that's just me and kind of how I think about mathematics. Because when I talk about restrictions, I want to list every single restriction. And the book says, and they're not wrong. There's nothing what they say is wrong, but they're saying because these two restrictions are still here, they're still part of our answer, we don't need them because they're there. So the main ones that we would look at is a minus 4, which would tell us it can't be 4, and negative 5. Right? And let me get my purple back. Now, I would say we also need what? A negative 3. Because even though they're still listed, I still want them to be part of our restrictions. And our negative a minus 4 and a plus 5 that were on top of this fraction are still listed, are still included in our restrictions, so we do have them all. We do have all these restrictions here. Any questions on any of this here? How do we feel about these here? You feel good with these here? Yes? We're going to stop here. We're going to stop here. And we'll finish this up tomorrow. We'll probably just do this one, and I think there's... Yep. So we have this here, and then we have some where we're not technically given two fractions. We technically they are fractions, but they don't look like it. Yes. So these will be over 1. And that's what we'll finish.